Hi, I'm Abhishek and I present our work SimGlim, simplifying glimpse-based active visual reconstruction. This work is in collaboration with Soroush, Seifi, and Tinne Description. Typical computer vision applications assume the input to a perception model to be the entire image. However, in practice, devices that run these models are limited by memory, processing, field of view, and other physical constraints that limit these agents from observing the whole scene at once. A more realistic scenario is where these agents make a series of partial observations, or what we call glimpses, of the whole scene with one sample at a time. However, not all glimpses are equally important. Some provide more information about the environment than others, and hence, for a limited glimpse sampling budget, learning optimal policy is required. In this paper, we present a simple agent to solve this task of active visual reconstruction. We have three major contributions. We simplify prior work that employ multi-stream networks and complex formulations. We utilize the multi-headed self-attention module to simplify heavy and computationally expensive memory modules in the prior work. Finally, we show that our proposed SimGlim model outperform naive exploration by self-supervised models trained on similar batch-based reconstruction tasks, showing the importance of learning an optimal exploration policy. Let's first look at how our model performs this glimpse-based exploration. Given a scene, a random first glimpse is sampled. Based on this observation, the model reasons about the whole scene and provides a reconstruction. Simultaneously, it decides the next best glimpse location to perform the glimpse sampling. This additional observation is then processed along with the previous glimpses to improve the reconstruction. Similarly, this is repeated k more times iteratively to improve the reconstruction. When all the glimpses within a fixed sampling budget is exhausted, we stop our exploration. We see that our model is able to provide meaningful reconstruction of the whole scene with only a limited observations across different datasets. Here we show our proposed architecture. At any kth time step, the observed glimpses are first processed to a context extractor module, which encodes the global context of the scene given the observations. This context is fed to the task module, which outputs a latent representation vector, which is then fed to a reconstruction head, which reconstructs the whole scene. A loss is computed with respect to the ground truth. Additionally, the glimpse module processes this latent representation into a predicted loss map that represents the loss incurred by the reconstruction head. The glimpse module is trained against the actual loss incurred by reconstruction head. The maximum region within the predicted loss map is used to sample the next glimpse location. This process is repeated till the sampling budget is exhausted. We evaluate our model on Sun 360, ADE20K, and MS Coco. We outperform the previous state-of-the-art benchmarks, which also shows a better reconstruction performance. Saliency for reconstruction is a property of the scene, and we see that our model attains same set of regions irrespective of the first random sampling location. This shows that our glimpse sampling policy learns to attain these salient regions. For more information, please visit our poster.